All right, so we're checking your understanding on problem number 13. I realized when I started looking at this assignment that that I don't think that you guys know how to read this part right here. So it's kind of confusing for me because one, I'm not making every one of the videos, so I'm jumping around in the book. So I can't remember if, but I don't think so. I don't think you've done portions. I think we're going to do that in lesson 18. So I just want to explain to you that this right here is saying that the scale factor can be found from comparing uh, the corresponding parts, the corresponding sides of a pre-image and its image. And that's what they've done. They've taken the length of side RS from the triangle and they found out that it's 2. And they've taken the length of R prime S prime and found out that it's 5. It's actually 10 over 4, I believe, 10 over 4, and then they reduced it to 5 over 2. But anyway, the bottom line is right here, I don't want you to worry about this notation because even though you may not understand what it's saying, they're basically telling you right here that the scale factor is 5 over 2. That's what they're telling you. Or you could say K is 5 over 2. That's all you really have to understand right here because we'll learn about this notation in the next section. So I don't really understand why they're doing it right there. But anyway, they want to know, is it a reduction or an enlargement? So basically all you have to do is say, what's the value of 5 over 2? It's a fraction, but is it a number bigger than 1 or is it a number between 0 and 1? It's greater than 1. So since it's greater than 1, it is an enlargement. Then they said, okay, find the coordinates of S prime. How do you find the coordinates of S prime? You take the coordinates of S and multiply each one of them by 5 over 2. So 0 times 5 over 2 is 0. That's where that number came from. And 4 times 5 over 2 gives me 10. And that's where that number came from. So those are the coordinates of S prime. Now it says triangle RST is mapped onto R prime S prime T prime by a composition. So what are they going to do? They're going to do 2 transformations. And the transformation that they're going to do first is the dilation. And then the transformation that they're going to do after that is the transformation. The shifting right 2 and down 5. So what are the coordinates of R prime S prime T prime? Now, first of all, I wouldn't call that R prime S prime T prime. The final results should be called R prime prime S prime prime T prime prime, but I tried to follow along what they said. So if I dilate these from here to here, these are the dilation coordinates. And then if I take these dilation coordinates and add 2 to the x value, 0 plus 2 is 2, and then subtract 5 from the y coordinates, 0 minus 5 is minus 5, there's the final coordinate. And again, you take the dilated coordinate and you add 2, subtract 5. So I take 0 plus 2 is 2, 10 minus 5 is 5. And then add 2, get 9.5, subtract 5, get that. So this is your final answer. I mean, this is what they have right here. 2, negative 5, 2, 5, and 9.5 minus 5. So those are your answers right there, but this is how we got it. And then I do want to show you what it looks like to actually do that. So the first thing we do would be to dilate this. And to dilate it, we make this side 5 over 2 times bigger than it is. Whoops. We make 5 over 2 bigger than it is. So this side right here is 3. 3 times 5 over 2 was 7.5. So we would move that out 7.5. And then this side right here that was 4 units tall, 4 times 5 over 2 came out to be 10. So we would stretch that up there. So there's the dilated image right here. So after we dilate that image and we get these points, you'll see that that's what they are right there. Then we're going to shift it to the right 2. So we're going to shift it to the right 2. And then we're going to shift it down 5. 1, 2, 3, 4, 5. And these coordinates, there's a little bit of, it's off just a smidge. Oh well. These coordinates right here should match these coordinates that we have over here. So let's see. 2, 5 is right there. 2, -5 is down here, and 9.5 down 5 is right there. So there's this is, let's see, S prime, this is R prime, and this is T prime. So this is what it looks like. We dilated it and then we shifted it, and there's the final answer. Okay, so moving on, I'm on page 244 now. And on page 244, on page 244, they say Kate wants to dilate the triangle ABC with a scale factor of 2 and a center of -2, 4. So this is what's changed, okay? On this problem that we had over here, when we did a dilation, and let me see if I think I've got it here. Sure. When we have a dilation right here, if we simply take all those coordinates that we had, let me get so where I can write on it. If we simply take each one of these coordinates, let's take this one right here, the point -2, 4. And she told us that the scale factor was 2. So if we take that point and we translate it, we transform it, so it's a dilation of 2. -2 times 2 becomes -4, and 4 times 2 becomes 8. Okay, so just by multiplying it, what we're doing is we would get this. But what we didn't say before is that when you just do this multiplication, it's understood that this center of dilation was the origin. And really and truly, what you're doing when you are rotating about the origin is what's changing is the distance from the point of the point of dilation, the distance from the point of dilation to one of the endpoints. So I just measured how far it is from A to D, and it's about 4.5. I've already done this before, so I know that it's really not. It's 4.47 something. So you're going to see a round off error here in just a second. But the distance from 0, 0 to this point right here is about 4.5. Now you know how to do the distance formula, so you can find the distance of these two right here. I think it's the square root of 20, the square root of 20. Now, if you take that distance, and I apologize for my barking dogs, of course they're going to bark during my video. If you take the distance from the center of dilation to point A, and then you are going to double the distance from the center of dilation to point A prime. That's what doubles. So notice that AD right here was about 4.5, and this one is 8.9, which really rounds up to 9, so that you can see it's the distance that doubled. The reason that the coordinates are doubling is because we're at the origin. And if I went back and measured, like from the center of dilation to B, I can measure from there to B, that's 2.2. And then when I measure from the center of dilation to B prime, it should be about 4.4. So let's see what it is. It's about 4.4. So this, again, there's a round off error. And this one right here is going to be exact. The distance from the center of dilation to point C is exactly 1, and the center of dilation to C prime is exactly 2. So that's what you're doing, is you're doubling the distance from the center of rotation to that. So when you change the center of the center of dilation, when you change that, then what you're doing is you're changing from where you measure. So in other words, what I'm going to have to measure, here's the center of dilation that they want me to do. So I'm going to take all the distances, so this distance right here, and then I'm going to take this distance right here, and I'm going to double them. So however far it is from here to here, so we can kind of, we say it's down 2/3. If the scale factor is 2, we're going to double that, go down 2/3. And that's where it's going to end up when we double the distance from here to here. And then again, the same thing is here for the distance from here to here. We're going to, this is what, down 4/3. So go down 4/3. And this is where you'll end up. And I can prove it to you by doing a dilation from this shape, from that, and the scale factor is 2, and you say okay, and then you see that we doubled that distance from that point. So you can have a center of you can have a point, any point be your center of dilation, and then you would just say how far is it from that center to this point. Well, if the scale factor is 2, then double it. If the scale factor was 1/2, then you would take half of it. But that's what's changing, okay, in this problem right here. So they want us to take this problem right here, and they want us to increase the size, enlarge it by a scale factor of 2, and they want the center of dilation to be -2/4. Okay, so here are the ways, here's how you can do it. You can do it algebraically, or you can do it using distance formula, okay? So you can find the distance from here to here, and then go from here and double it, and you'll find your new point. So you can do it that way. Or you can use the center of dilation, which is -2/4. So that means in this problem, our A value is -2 and our B value is 4. So this will always be, if this is the center of dilation right here, will always give you your A value and your B value. And then, of course, your scale factor is the value of K. And then you just have this formula. But what they're explaining, what they're doing is, here's basically what's happening. The first thing they say is, okay, we know that the center of dilation is not at the origin, but let's pretend for a second that it was. And the only way to pretend for a second that it was is to take your image and move it to the origin. So now that I'm at the origin, now I'm going to double its size because the scale factor is 2. And then I'm going to shift it back to where I started from and then see where the coordinates are. Okay, so that's what they're doing. It says you need to subtract the coordinates of the center of dilation from the coordinates of the preimage. That step right there. Let me see if I can't highlight it. That step right there, you need to subtract the coordinates of the center of dilation from the coordinates of the preimage. That step right there is what we're doing right there is moving the image to the origin. Okay, we're moving the image to the origin when we do that. And then, let me highlight this. Multiply this new number by the scale factor. When we do that, that multiplication is we're dilating our image. We're dilating our image. Okay, and then the third step is we're going to add the coordinates back. Add the coordinates back. Then we're just simply moving our new dilated image. We're moving the dilated image back to the center of dilation. Okay, so we move it to the origin, we dilate it, then we move it back where we started from. That's what subtracting a from the x value is going to do. That's moving it to the origin. Multiplying by k is dilating the image, and then adding the a back is moving it back to the center of dilation. So I can find out where these coordinates are. It's off my grid paper, and I actually think I've got it drawn a little bit too wide, but it's off my grid paper, so I'm going to need to calculate this. So here I go. It's just going to be a matter of saying -2 plus, and then the k value is 2, and I could probably color code these to make it maybe a little bit easier. We'll say this 2 is the K, and then we'll say this 2 is the A. And then let's let the B be 4, be green. Okay, so we've got this A should have been red. So A is -2. And then we've got plus, and then K is 2, and then we've got parentheses, and then our X value, in this case, is -2 minus, and then our A value is -2. Woo, there's a bunch of 2's in there. That's just the Y, that's just the X value. Now, the B is green, so the B value is 4, and then it's plus, K is 2, and then we're going to multiply that times the Y value is 4 minus, and then the B value is 4 again. Okay, so to calculate this real quick, we're going to say 2 minus a -2. 2 minus a negative, that's 2 plus 2. -2 plus 2, that's 0. 0 times 2 is 0. And 0 plus -2 is just -2. So my new coordinate is going to be -2, comma, and then 4 minus 4 is 0. 0 times 2 plus 4. So my new thing. Now, didn't that make sense? Because A prime, you see on this red thing, when I stretched it out, A prime didn't move. Now, you do that same process. I'm going to speed it up because I'm already 18 minutes in. I'm going to speed it up and not do colors and just say A is -2 plus K is 2, X is 1, minus A is a -2, comma, and then B is 4 plus K is 2, Y is 2, minus, and then B is 4. So that becomes, let's go to the parentheses first. That's 1 plus 2, that's 3. 3 times 2 is 6. 6 minus 2 is 4. 2 minus 4 is -2. -2 times 2 is -4. -4 and 4 is 0. So that means that I have a new coordinate at 4, 0. Oh, look, that's where my thing should have stopped. So I know to back this up to right there. Okay, and that's going to be almost perfectly double. And then you do the next one. I do have this over here. Calculate that last number yourself, and here's what it should come out to be. So A was at -2,4, and -2,4 was my center of dilation, so A doesn't move. It ends up right back at -2,4. B was at 1, 2. We double it, and it becomes 4, 0. And then C, which was at 1, 0, moves to 4, -4. So that's that process. I think the next problem that you're supposed to do, whoops, I'm showing you the wrong page. We just did 15, 16, and 17. So yes, that's what I thought. The next one is check your understanding. So go ahead and try to do that, and I will start my next video with the answers to check your understanding.